Hi, and welcome to day 27 of 100 Days of Code in IoT Challenge. As I promised, today I'm gonna be working with hardware again. I've got this new PIR sensor, a motion sensor, model HC-SR501. And today I'm gonna do basics. So my plan is to build a very simple circuit, including this sensor, a diode, and obviously ESP8266 microcontroller. But yeah, let me show you all the parts and components now. So today we have a breadboard with ESP8266 already attached, HC-SR501 movement sensor. This is a standard PIR sensor. It is infrared. This is how it detects movement using infrared light. Since that sensor needs a 5 volts of power supply, I'm gonna use this power supply module. It is very common. You can find it in most of the development kits for Arduino and ESP8266, ESP32. I've got AC adapter. This is needed to supply power to the power supply module here. A green diode that's gonna switch on when the movement is detected. And then I have a bunch of wires, 3 wires to connect to the movement sensor, 1 wire to create a common ground, and 2 wires to connect the diode to our circuit. And final part is this USB to micro USB cable to connect microcontroller to my computer. And let's assemble our circuit. So what I need first is the breadboard with ESP8266. I'm gonna connect a power supply module. It's gonna fit into the breadboard in a nice way. It was actually designed this way to be nice, right? And right away I'm gonna connect my AC adapter to the power supply module, and then the other end is gonna be connected to the fuse. Okay, that's connected, and now you can see when I switch this on, this diode here switches on as well. I'm gonna keep it switched off though for now. Okay, let's connect the sensor. So what we're gonna do is have a look at datasheet now to find out about these pins, what are they for. So I've got the datasheet here, and yeah, as I mentioned, and as you can see here, the voltage is between 5 and 20 volts. That's why I need a power supply in the circuit today. What else is important on this datasheet is the fact that we can adjust sensitivity and time delay, and also there are 2 modes that this sensor can work. But I'm gonna show you in practice how this all works. Anyway, as we can see on the datasheet, as I'm holding it in exactly the same perspective, right, we have the adjustments here, right, on the bottom. The pin on the left is the ground, the pin on the right is the plus, and the pin in the middle is our output. So what I'm gonna do for that is we're gonna use the red wire for the plus, the gray one for the ground, and the dark purple is gonna go to our output, right? So yeah, I actually use the red one and the gray one on purpose, so we know the red is plus. It is usually plus, right? Okay, so that's how I connected them here. And now the other end of those wires, they're gonna be connected to the breadboard. So first of all, we need to check what is the voltage on those supply lines. And here we've got 3.3, right? Because the jumper is right here on 3.3 on the power supply module. I'm not sure. Yeah, I think now it is visible. And on this side we have 5 volts. Right? The jumper is on 5 volts. So this is set to 5 volts. This is set to 3.3. We could power the board from these power lines, but not from this. If we do from this, we would damage the board. But we're not really gonna be powering the board right now from the power supply module, because this is gonna be done by the USB cable. We just care about powering our sensor. So what I'm gonna do is to connect this red wire to the plus, and then the gray one to the minus. So maybe like here, right? And then dark purple is gonna go to one of the digital pins. I'm gonna choose D1, simple choice, right? So now this is all connected. And the last step for connecting the sensor is gonna be connecting the ground of the 5 volt supply line, the ground, to the ground of the board here, right? It can be any ground of the microcontroller, but you know, I've just chosen this one. Okay, so now that should be all done for the sensor. And the last bit is gonna be this diode. And the diode is gonna go somewhere here, so let's maybe just do it somewhere here. Like yeah, we don't have much space, but what is important here is this longer end of the diode, right? This is where we need to connect our digital pin to. So let me just connect it here, right? I've got it here. And now I'm gonna use the red wire to connect it to, maybe let's do D2. So we have D2, and then this is gonna go here. That was the longer end of the diode, right? Then there is a gap in the middle, and the one on the right is our ground. And that ground is gonna go to one of the ground pins here, maybe this one. Okay, so let me just quickly go through it again, right? So here, looking from that perspective, the left pin, the ground, connected to the ground of the power lines, here 5 volts. Then the red one is a plus, and that is connected to the plus of the power rail, 5 volts. The dark purple one is connected to D1 here, right? And then we have a red wire connected to the longer end of the diode, and the white wire connected to the ground of the microcontroller. And the last wire, the blue one, is connected to the grounds of the power rail of 5 volts coming from the power supply to the ground of the microcontroller. Okay, so yeah, the very last step is really just connecting the USB here, switching on the power, and now let's move to the code. I'm gonna show you how to write the sketch to make all of this working. It's gonna be pretty straightforward. So here we're gonna start from creating a new PlatformIO project. So I'm going to PlatformIO quick access open. We've done this many times, right? New project, and this is gonna be called Motion Sensor. Board is Node MCU. 1. Framework Arduino location, default location. The project created, and again, let's start from setting the monitor speed, and that's gonna be the value that we want to start the serial monitor. 5 seconds delay for the serial communication between the device and IDE, and And yeah, that's what we need on the platform.ini. We're not gonna be using file system today. And then in the main.cpp, yeah, I don't need that command in the loop. Now that we have initialization done, let me quickly show you the simplest example, which is gonna be just with digital read and digital write. However, one thing that we need to look into is this one instruction from the datasheet about the fact that the motion sensor has to calibrate itself, and that takes around 1 minute. As you can see here, sensor module is powered up after a minute in this initialization time intervals. During this module will output 0 to 3 times. A minute later enters the standby state, and this is the state that we need the motion sensor to be able to see whether there is a movement detected or not. Okay, so now, because I'm not gonna be using my core library and the timer class, and I would like to show you the simplest example without any externals here. For this one, you're gonna have to wait a minute on your own, right? So what I'm gonna do, once I deploy the sketch, there's gonna be 1 minute gap, but essentially on the video, I'm gonna skip it. But I will wait 1 minute before I connect to the serial monitor. So you should see the calibrated output from the sensor, okay? But yeah, okay, let me show you in the loop function. It is as simple as reading the data from the digital pins. So we have our output pin of the sensor connected to D1, and that's what we want to do. We want to check if D1 is high. If the voltage is high on D1, that means there was a movement. Movement detected. That's what I'm gonna print out. And also what we want to do is to switch on the diode. So digital write, and that's D2. I'm gonna change the voltage to high. Okay. However, as I'm going to write to the diode, I need to initialize it here. Essentially just set the mode. So pin mode D2 is gonna be output, right? So that should just, initialize the diode. Right. If the digital read on D1 is low, that means there is no movement. Right. And what we want to do is to set D2 to low. Right. Okay, this is pretty much it. I'm gonna deploy it now. And as I said, once this is deployed, I'm gonna wait a minute here. So if you're copying my steps, you're gonna have to wait 1 minute before, ideally before you even connect to the serial monitor, right? So the minute has passed, and I'm gonna connect to the serial monitor now, and I'm gonna switch to the breadboard view. So as you can see, the diode is off, and on the serial monitor we have no movement detected, right? Let me put my hand in front of the sensor. Okay, as you can see, when I put it here, yeah, there is a slight delay between the detections, right? I have noticed when I was experimenting with that. Yeah, I still have my hand around. Yeah, there is this delay after the movement detection. It is 4 seconds. I checked it on my own, but I would like still do it with you on this video to take all of those measurements and maybe check how this sensor behaves when we have a different adjustments set here. Okay, right. But before I change anything here, I will have to modify my code to take all of those measurements. So let's move back to IDE. Okay, and now I'm gonna modify the code. However, first let's think about these measurements that we want to take. So one measurement I've just mentioned is gonna be the time between the moment the sensor stopped detecting the movement and the next detection, right? There is a delay. We would like to measure this delay. So for that, I'm gonna make use of a millis function. However, to utilize this function, we're still gonna have to declare some variable, some unsigned long variable, and I'm gonna call it T1 maybe. So that's gonna be the first measurement, and the second measurement, I'm thinking about like this delay. The first one that we would like to measure is gonna be between the moment. It's gonna be between when the movement is not detected anymore and becomes detected again, right? So that's gonna be so that's gonna be more like on the transition of state from no movement detected to movement detected, right? So this is gonna be our T1. I can even comment this here. So we have no movement into movement, right? So from the moment when it's not moving anymore until the moment when the movement detection happens. And the second measurement, I will do the other way around. So we have movement and then we don't have a movement, right? So the time between the moment that essentially I can give you an example with the diode, right? So this is the time of the diode being switched on, right? So once it switches on, the movement detected, we start measuring, and when it switches off, we stop measuring. Okay, let me show you in the code how this is gonna look like, right? So let's think about this transition first. We have digital read high, right? To find out, there was a transition actually. So this is not like, because this happens in the loop. It happens continuously. And what I would like to have is some sort of a previous state. So I can make sure the previous state is not the same as the actual one, right? We're interested in transitions. So I'm gonna define another variable, and this variable is gonna be int, let's just call it previous state, something like that. And that previous state, I'm gonna initially set it to low, right? And then how this is gonna work. So if the previous state is low, okay, and now the reading is high, this is where we had the transition. This is where the state changed from low to high. If we have two lows or two highs, we don't care, right? So essentially, I'm gonna modify it slightly in the way that we first take the measurement of the digital pin, so the digital read, okay, and then we check if the current state, okay, is different than the previous state. This is what we care about. And if the current state is high. That's what we really care about, right? So that condition indicates that the previous state was low, right? Because if the current state is high, then the previous state has to be different than current state, and the only other option is low. So that means we have the transition from low to high. And this is the moment where the movement is really detected. And this is the moment where I do the println movement detected, and we change the voltage on the diode to high. So we're switching it on, but also this is gonna be the moment I would like to take the measurement, right? Because the diode switches on, and I'm gonna set a T1 to millis. This is a current time in milliseconds, right? So this is the time the diode has been switched on, right? Okay, so this is the first condition. And then the second condition is going to be really still current state is different than previous state, and current state is low, right? So this can go inside. I could do something like that. We can have this condition here. I personally don't like nested conditions, but nested ifs, but I'm gonna make an exception today for this one, because I think this actually will be more readable if we have those conditions split, right? So this is just the other option, because there's no third state. There are two states, high and low. Okay. So if we have a difference between current state and previous state, and then the current state is high, that indicates the previous state was low, then we have the movement detected. We start measuring T1. And then if we have the different state, the current state and previous state, and the current state is low, right? So this second option here in the else, then this indicates the current state is low. And if the current state is low, we want to digital write to D2, so switch off the diode. And that's gonna be the moment where we can calculate the measurement on T1. How I'm gonna calculate it? I'm just going to do something like, let's say, T1. I'm gonna change this text in a second, but I need to think about what to put here, what text. Okay, so we have T1, and then that T1 is gonna really be the current time, and we're gonna subtract T1, right, the previous time. So we will have the time difference, which is gonna tell us how long the diode was switched on. Okay, but this is not everything. We still need to measure T2, which is between the this is actually gonna be the other way around, I think, because we calculate T1, and T1 is really when there is a movement and there is no movement anymore. So that should be our T2. I'm sorry for my mistake, but this is T2. T1 is gonna be here. So this is the moment where you want to set T1 equals millis. And this is gonna be the moment where I'm going to print this out. I will explain in a second. I will give you one more explanation in a second one. One second, let me finish this. So this is millis minus T1 now. Okay, so yeah, let's think about this T1, T2. So I'm gonna call it maybe T1 is really no movement and movement. So I'm gonna just print out something like no movement to movement time. And this is the other way around. So this is movement to no movement time, right? Time, there should be time. And that's gonna give us in milliseconds the movement. Let me just quickly go through this again, right? So yeah, remember this loop function executes continuously. It just goes on. This is why it's called loop, right? And it constantly checks for those two states, right? It constantly reads on D1 and checks the previous state. Okay, and I've actually realized I've got something missing. Give me a second, I will fix that. Maybe you noticed it already. So we check if the current state is different than previous state. Only if there is a difference, if there was a transition, we want to do something. All the other cases we just skip, right? We just, this is gonna just finish. It's never gonna go inside here. These braces. I think I also have a brace missing on the loop function, yeah. Okay. And okay, but let's say there was a transition change. And if that transition happened, we want to check if the transition is happening from low to high or from high to low, right? This one is from low to high, because if the current state is high, the previous state must be low. And this is when we have the movement detected, right? From low to high, right? No voltage on the sensor pin, the output pin, and voltage on the output pin. We have detected the movement. And this is the moment we also start measuring T2, which is the difference, right? T2 is the difference between movement and no movement, right? There was a movement and the sensor is on. And then let's have a look here, because this is really where we print this out, right? Here there is no movement anymore, right? So there's gonna be like thousands more iterations before this happens, right? Because that runs like 1,000 times in a second or even more. But at some point we'll have again the state, the transition of state, but this time from high to low, which is this case. And that case just gonna print out the difference between the current time and the measurement we took here on T2, right? And also it's gonna set millis to T1, which is this case, right? This case is the time between there was no movement and there is movement again. Cool. The one thing I missed is setting the previous state, because the previous state is always low now. What we have to do is to set this previous state whenever, I mean, this actually needs to happen at the end of the loop, right? So we know what the previous state was. So if current state is this one, at the end we can just assign previous state to current state, the last line on this loop function. So the next one is gonna take a new measurement on the current state, but the previous state is gonna stay as it was the iteration before. Okay, so that's gonna allow us to do all of those measurements that we need. And I also will be able to show you those adjustments on the hardware. Okay, let me compile this and we're gonna move to the breadboard view. Okay, we are connected to the serial monitor and now you see there is no messages yet because no movement has been detected and there is no transition of state. Now the diode is only gonna change its own state when there was a transition of state on D1, which is connected to the output of the motion sensor. Okay, let me just make some movements. As you can see now, this is working, right? Okay, so first of all, what I'm gonna do is to take the measurement of, I think that was T1. So this is the moment between the diode goes off and it goes on again, even though my hand is still gonna be in range of the motion sensor. So let me do that, right? I'm gonna put it here. And now I'm gonna move it and let's see. Okay, I'm gonna do it again. So let's wait until it goes off. Okay, and I'm gonna do it again. Okay, and one more try. So we'll have 3 measurements on this one. Okay, great. We have 3 measurements. Before I talk about those measurements, we can see them in the serial monitor. Let's try to do the other one, because the mode the sensor works at the moment, this is about the jumper here, is really if the sensor keeps detecting the movement, it's just gonna keep the state high on the output pin. So if I keep moving my fingers in front of the sensor, right, it doesn't work all the time, but yeah, let me try to do this again. So yeah, it went off, and I'm gonna try to do it again. And as you can see now, it keeps, this is still on, right? The diode is still on. And now, yeah, so as you've seen, as long as I move my hand, the diode is on, right? Because I'm moving, and this is the mode of the sensor at the moment. If I change the jumper, I can actually do it right now. So let me show you. So let me show you. So it's here, right? This yellow jumper. If I change it from here, to the very edge, okay, then regardless whether you keep moving, regardless whether there is a motion in front of the sensor, there is a fixed time after which the state of the output pin is gonna go to the low voltage. So let me show you this. So I'm gonna, yeah, you see? So I'm gonna keep moving my fingers, and this doesn't change anything, right? We still have a delay between the detections, but as you can see, it doesn't matter. The only way I could keep the state of the output pin of the sensor high is to increase this timeout on those adjustments. But yeah, quickly, let's have a look at the serial monitor. So when I started, we had this very long time because that happened before I connected the serial monitor and everything, right? And we have no movement, movement to no movement. This time is 5 seconds, as you can see, right? Then we again have no movement to movement, and this is the time, 19 seconds. But that wasn't the measurement. I took the measurements here. This is where I took the measurements, right? And as we can see, we have something between 3.2 and 4.2 seconds between no movement and movement. Oh, sorry, this one actually is movement to no movement. So it's this one, isn't it? So no movement to movement, we have 4.9, 4.2, and is there any other one? Yeah, there it is. No movement to movement, 4.3. So that's the average time I checked myself. I've done many more measurements on this delay between no movement and movement. So when the sensor is gonna detect the movement again, and this is around 4.2 seconds. Okay, so if you have the case where you would like to check if the object, your target, keeps moving, I'd suggest having some sort of the delay on this, maybe 5 seconds to be safe, and see if we have another movement in this time, right? Okay, let's see another example on the, so let's see how the measurement looked on the other side, right? So between the movement and no movement. So we have 2.7 seconds. Here we have 1.9. We have something like 8 seconds here. And there is also, I think there is even longer on the movement to no movement at some point, or this was I think this was the longest one. So that was the moment I kept moving my fingers. So that's 8 seconds, right? It can be even longer, but again, I wouldn't rely on the sensor that much because you really need to move. I tried to do it with my whole body, just standing in front of the sensor, and you really need to move. You need to dance in front of the sensor for the sensor to like keeping the output voltage high, right? So again, that's why I'm suggesting with doing this double, maybe triple measurements with this delay of 5 seconds between them, right? And what else here? This is the last on this measurement. Last thing on this measurement is when I change the jumper. And as you can see, those last measurements, they are all around 1110 milliseconds. Sometimes is 1109, right? And this is how the different mode on the sensor works. So if you switch it, then it's always going to be the same when the output stays high voltage, right? Let me just increase this delay on the sensor. Let's go back to the breadboard view. Okay, let me restart the serial monitor. Cool, so we start fresh. The first step, I'm just gonna grab my screwdriver and let me show you this. Let me zoom in. Let me show you this. So those two screws here. This one is sensitivity. This can go up to 7 meters, and today I'm not really gonna be experimenting with that because I don't really have conditions here. I would have to leave my house to check what is the maximum distance you can detect the motion from. So yeah, on this one though, this is the time adjustment. And for the time adjustment, what I could do, because now we have the fixed time of the output switch to high when the motion is detected, and I can show you this can go up to 3 minutes. So I'm not really gonna show you on 3 minutes, that's gonna be too long, but I could do like slightly adjust it higher, just slightly like this, right? You see, this is the minimum position I've got here, and this one was just slightly increased. And now let me show you in the serial monitor. Okay, and yeah, this one essentially doesn't care if the movement is still continued, right? So if I do that, we still get 1159, right? 1158. Actually, this didn't increase that much, and I think the reason might be the requirement of calibration when you change those adjustments. So let me recalibrate it. I'm gonna switch it off and on again, and I'm gonna wait a minute. Okay, the minute has passed, and let me make some motion here. Okay, and we still got 1150, which is not something I would like to get. So let me just increase it even more, maybe up to here, and let's see what's gonna happen now. Okay, I think this one is already longer. Yeah, this one is definitely too long. I need to decrease it now. What about this one? Yeah, this one seems to be much better. So now we have like, I think we have 3 seconds. And even if I keep moving, yeah, we have something around, this is 2.9 seconds. Let me try one more time. Yeah, this is 2.8, 2.9 seconds. So yeah, it is a bit weird the way this works, because like if you just adjust it slightly, it stays on 1.1 seconds, and then at some point it suddenly goes higher. But yeah, anyway, how this behaves if we have the jumper set like that in the non-fixed mode, in like keep detecting the movement, is essentially still gonna work in the way. Let me just show you that there is this 4 seconds delay between the detections. So yeah, 1 second. I think now it is more sensitive. Okay, so I'm gonna keep moving my fingers now, and let's see how long this can be. Okay, that's probably gonna be way longer. gonna stop moving now. Okay, so yeah, this one actually is nice. It was 16 seconds, so it was quite nice. So apparently we can adjust it with this. We can adjust the sensor with this one. So we may not need to do the double measurements. We can just rely on this time adjustments, right, with this mode. It is working quite well, to be honest. But yeah, anyway, for today this is gonna be it. You might be wondering why I have done very thorough tests and measurements, right? And this is because I've got a project in my mind that I'm gonna do tomorrow, and this is gonna be automatic LED lights. But the details I'm gonna show you tomorrow on the video. If you have any questions regarding this topic, so just a sensor, and for example you would like me to do some experiments with the distance adjustment outside, or you would like me to test a different type of sensors, please let me know in the comments. And that's it for today. If you like the content and you want to stay up to date with my channel, hit the subscribe button so you will get notified as soon as I upload the next video. Thanks for watching and see you tomorrow.